So welcome to this latest video on 162 Maths, and in this video we'll be going over a GCSE Maths higher topic test on similar shapes and triangles. Now as always, I'll include a link so you can access the questions that we go through in this video, and all you need to do is just simply click on the link in the description, where I'll also include a link to a lesson which goes over this topic in more detail. Now before we get started working through some past exam questions relating to similar triangles and similar shapes, let's just have a quick overview over the whole topic. Now a similar shape is a shape that's been enlarged where the dimensions have been made bigger or smaller. For a shape to be similar, each side must be enlarged by the same scale factor, and that's really an important concept that we need to be able to know. Now the other thing is that when you're talking about enlarging a shape, you're not automatically always going from a small shape to a big shape. You can be going from a big shape to a small shape. Now the scale factor, now this is calculated in many different ways, and your teacher or your websites and different videos etc. may go through different methods of finding the scale factor, but I found that the one that's probably the most efficient is recognizing this picking a side on the new shape that you know the length of and dividing that by the corresponding side on the original shape or the old shape. Now this will therefore give you the scale factor. Now you need to make sure obviously you've got length of each of those sides, and you'll always tend to find that there is always going to be one side of the same side on both the shapes that you know. Now you might need to change the orientation of one of the shapes, but generally speaking they will always give you one. Now once you've got your scale factor, if you're wanting to go from your old shape to your new shape, then all you need to do is multiply by the scale factor. If you're going from the new shape to the old shape, then here you need to divide by the scale factor. Now with this, you've got to have an element of and use an element of common sense to help you get the right answer. So always think to yourself, am I expecting the answer to be small or bigger than the side of what I'm working with? And then decide whether you're multiplying or dividing. Now if your answer doesn't look correct, just simply change the sign of what you did. So if you multiplied and it looked a bit wrong, then go for dividing. If you divided but the answer doesn't look right, try multiplying, and you should hopefully get an answer that seems a bit more realistic. And the other main thing is that similar shapes always have the same internal angles. So although the sides are changing, the angles inside the shape will never change in a similar shape. Now before we get started working through these questions, a little reminder that you can download these questions simply by clicking on the link in the description. So looking at question 1, it says which triangles are similar to triangle A? So triangle A is this triangle here, and looking at the properties of triangle A, we know it's a right angle triangle and we've got sides of 2 and 2. So again, what I can do is I can dismiss any non-right angle triangles, because obviously the angles inside this triangle, it's actually also going to be an isosceles triangle, and so that's going to be 45 and that's going to be 45. So that means that it's definitely not going to be B, it's definitely not going to be G. And then looking at the sides, on E I've got 2 and 3, so that's not going to be correct. On H that's 3 and 2, so that's not correct. J is 3 and 3, well that has been, so that is an isosceles triangle. F is 1 and 1, and that is an isosceles triangle, so that could be correct. D is 1 and 1, so that is correct. And C is definitely not, so the correct answers I could have are going to be D, F and J. Then moving on to question 2, it says, are these triangles similar? So I can see straight away that they are not going to be similar because the internal angles are different. So internal angles are different. And again, if I wanted to, I could work out what this angle here is. So it's going to be 180 minus 90 minus 56, which is 34. And this angle here is going to be 180 minus 90 minus 28, which is 62. So the internal angles are different. Moving on to question 3, it says triangles ABC and PQR are similar. Angles BCA and angle BPRQ are the same. And it says work out the angle of QPR. Now QPR is this angle here, So this angle here is going to be 30. So to work out this angle, all I've got to do is do 180 minus 30 minus 90, which gives me an answer of 60. Then it then says work out the length of BC. Well, first things first, what I need to do is work out the scale factor. So I'm looking for which sides do I know that's the same on both triangles, which I've got a length for, which is PR and AC. So the scale factor is going to be 7 over 2. And I'm going to go from, and the question is asking me to work out BC, which is this length here. So I'm going from the new shape to the old shape. So I need to divide by the scale factor. So it's going to be 6.1 divided by 7 over 2 equals x. And if I type that into my calculator, I get an answer of 1.74, and that's to 2 decimal places. So then moving on to question 4, it says work out the length of length x. Now with this, what you need to do with these types of questions, and if you don't see it now, you will do from once I've showed you, is basically you can draw your two triangles separately. So looking at this triangle, it's 6 and it's x, and on the big triangle this is going to be 18 and this is going to be 10. So because again, the two triangles within the shape are this here and this here. So then from this I can use 6 and 18 as my scale factor. So the scale factor is 18 over 6, which is 3. Now x, I'm going from the big shape to the small shape. So x equals 10 divided by 3. So x equals 10 over 3, which is 3.3 recurring, or 3.3 to 1 decimal place. Again, your choice of rounding is entirely up to you. Now moving on to question 5, it says are triangles ABC and PQ similar, congruent, or neither? And you must give your reasons to show you're working out for your answers. Now for this, because they're triangles and we've got the two internal angles, what we need to do is we need to work out what these internal angles are going to be. So again, knowing that angles inside a triangle add up to 180, I can then work out what this angle here is going to be, and that's 67. I can then do the same for the other triangle and work out the missing angle, and this angle here is going to be 65. Now the key thing I need to spot is that looking at the sides, I've got a side of 4.2 centimeters. However, on triangle ABC, the 4.2 centimeter side is on the side that's got the 65 and the 67, whereas on the other triangle the 4.2 is on the side of 67 and 48. So here, because all the internal angles are the same, they are similar, as the internal angles are the same, however 4.2 centimeters is on different sides. Now in order for them to be congruent, then the 4.2 side needed to have been on this side here. Then moving on to question 6a, it says describe a shape that is similar but not congruent to a rectangle, a regular hexagon with sides of 5 centimeters. So for it to be similar, basically it's going to be a regular hexagon with sides of, and you can actually pick any number you want, because if it's a regular hexagon, a similar regular hexagon is going to still be a regular hexagon with all the internal side being the same and all the lengths being the same. So you can pick absolutely any number. So I'm going to go for, let's say, 6 centimeters, 10 centimeters, 20 centimeters. That's absolutely fine. The key bit of information you need to write is this, and then you just pick any number to follow it. Then for B, it says describe a shape that is congruent to a circle with a radius of 2 centimeters. Well, for it to be congruent, it needs to be exactly the same. So either you can write a circle with radius of 2 centimeters, or if you want to change your words up, you can say a circle with a diameter of 4 centimeters. But both those two are the same thing. Then moving on to question 7, it says triangles ABC and JK are similar, and it says work out the values of X and Y. Now with this, what you want to do is you want to make sure that both triangles are the same orientation, just so it's easy for you to spot which sides you need to use for your scale factor. So if I just label this as 40 and 87, then on the other shape, I've got 40, I've got 87. Now the side with both of those is X, and the side with 87 and L is 13, and this side here is the 20. So then to find the scale factor, I'm going to use 20 and 12. So it's 20 over 12, which is 5 over 4, and that's going to be 5 over 3. So then to find X, I'm going from small to big, so therefore then it's going to be 10 times 5 over 3, which is 50 over 3 centimeters, or if I wanted to write it as a decimal, it's going to be 16.7 centimeters, and that's to 1 decimal place. If I wanted to work out Y, well, Y is going from big to small, so that's going to be 13 divided by 5 over 3, which if this was on a non-calculator paper would be 13 times 3 over 5, which would be 39 over 5 centimeters, or if it was on a calculator paper, I'd actually work that out, and it's 7.8 centimeters. Then moving on to question 8, it says AB and CD are parallel lines. AD and BC meet at X. Show that the triangles ABX and DCX are similar. So for this is a case of looking at geometric proof and looking at congruent and similar triangles. So here we want to show that the angles are going to be the same. So we know that angle ABX is equal to CXD because they are opposite. Now we know that the two lines are parallel, so that means that this angle here must be the same as this angle here. So angle BAX is equal to XDC because they are alternate. And for the same reason, we can then say that this angle here is the same as this angle here. So ABX is equal to XCD because they are alternate. So therefore, as all internal angles are the same, triangle ABX and triangle CDX are similar. It then says work out the length of XD. So if I start by drawing those two triangles out, so let's start by looking at this, and let's colour code the angles. So we've got purple here, let me actually draw the other one as well. So I've got my two purple angles here, I'll have my blue angle here and my green angle there. So then labelling all of this up, we know that the bases are 4 on the smaller one, 10 on the bigger one. The angle with the green and the purple angle is 5, and the question is asking me to work out the side of XD, which is the side of the purple and the green, so that's my angle X. So this is X and that's D. So then the scale factor is going to be 10 over 4, which is 2.5. So then to work out X, it's going to be going from the small shape to the big shape, so I'm going to multiply by 2.5. Now sometimes it's easier to work with fractions when you're on non-calculator paper, so that's going to be 50 over 4, so that's going to be 12.5 centimetres, and there is my answer for 8B. Now moving on to question 9, it says A, B are similar shapes. B is an enlargement of A with a scale factor of 2.5. Work out the lengths of A and B. So we know that the scale factor is 2.5. So then to work out B, well, that's going from the small shape to the big shape. So I multiply by the scale factor. So it's going to be 17 times 2.5. And again, if this was on a non-calculator paper, then I should do 17 times 5, which is 85 over 2. Oh, 85 over 2, not 82 over 5, so 85 over 2, which as a decimal gives me 42.5. And A is going to be 46 divided by 2.5, which gives me an answer of 92 over 5, which is 18.4. And they're both in millimetres. And there we go.